Getting into chapter 12, we're going to talk about cancer epidemiology. What does this mean? It's a branch of medical science that investigates all the factors that determine the presence or absence of a disease or disorder. We know that cancer can develop from predisposing factors, including genetics, epigenetics, environmental, lifestyle factors, altered metabolism, altered biological processes, and exposure to carcinogens, which are cancer-causing substances. You can imagine then that many forms of cancer are preventable, especially when predisposing factors are including high-risk activities and exposure to carcinogens. In Table 12.1 of your book, there are key associations and causes of cancer, like eating processed or red meat, infections, hyperglycemia or diabetes, lack of fruit and vegetables, alcohol, sun exposure, tobacco. Patterns of cancer are usually influenced by one's environment. We see that genetic and epigenetic alterations drive cancer at the cellular level. And then the external environment also influences these factors. Cancer development is also influenced by the surrounding supportive tissue, or what's called the stroma. Chronic inflammation of the stromal tissue can initiate cancer changes as well. In 2018, there was an estimated 18.1 million new cancer cases and 9.6 million cancer deaths. Cancer is a major cause of morbidity and mortality worldwide. In the United States, cancer seems to be decreasing for men, staying the same for women, and increasing in people 0 to 19 years of age. In both sexes combined, lung cancer is the most commonly diagnosed cancer, and it's the leading cause of cancer death. Female breast cancer and prostate cancer are closely behind. In males, lung cancer is the most frequent cancer and cause of death, and for females, it's breast cancer. Generally speaking, however, the death rates in the United States are decreasing for men, women, and children. However, those with liver cancer have experienced higher death rates overall out of all of the cancer types. And in men with liver cancer, it's more than double the death rate than women. So it was thought for a long time that there was a long latency period before the onset of adult cancer. But what we're finding out now is that early life events increase our susceptibility to certain chronic diseases. What I want to talk about here is developmental plasticity, and this is important for you to know. It's the degree to which an organism's development depends on its environment. Plasticity refers to the ability of beings to organize in response to an environmental condition during our fetal development. Nutrition and other environmental factors affect our cellular pathways. This is when mom is pregnant with us. It allows a single genotype to produce a broad range of phenotypes. Mom's nutrition and the environmental factors around her are very significant here in our development. If there are persistent epigenetic adaptations during pregnancy, that is associated with an increased risk for cancer. The Dutch famine birth cohort is a well-known study on the effects of prenatal undernutrition and how it is linked to heart disease, metabolic disorders, and possibly breast cancer later on in life. Overall, undernutrition during the first trimester results in increased vulnerability to disease, especially in outcomes in adults. One of the best examples of an early life trigger to future cancer in utero was exposure to DES, and you can see that on your slide. This was a synthetic estrogen. Between the years of 1938 and 1971, it was a treatment for threatened miscarriage, premature birth, and abnormal bleeding. But by the 1950s, they discovered that DES actually altered the development of the reproductive system in the fetus and those who were pregnant with little girls, and it did not prevent miscarriage. So now there are studies that reveal that the daughters of women who took that DES during pregnancy may have an increased risk of breast cancer before the age of 40. Now we're going to talk about environmental lifestyle factors and how they are important risk factors for cancer. There are several environmental factors like pollution, radiation, sunlight. All of these things can cause risk. But if you put them together with lifestyle factors like smoking, alcohol, lack of exercise, obesity, that could increase our risk even further. You can see here on the visual how these factors work together to alter our epigenetic marks. It causes an abnormal expression of tumor suppressor genes and oncogenes, and therefore increasing our risk of cancer. Tobacco use. What I want you to know about tobacco is that it's the most important environmental risk factor for cancer. Tobacco is the most important cause of preventable cancer. Smoking is linked to so many of the cancers that you see on the slide, and it affects nearly every body organ. 16 million Americans are living with a disease that is caused by smoking in the United States. And smoking also accounts for over 500,000 deaths each year. 40,000 of those deaths are from secondhand smoke. Worldwide tobacco use causes more than 7 million deaths per year, and on average, a smoker will die 10 years earlier than their counterparts. We refer to secondhand smoke as ETS, or environmental tobacco smoke. This is a combination of what's called side stream smoke, which is the smoke from the burning end of the cigarette, and mainstream smoke, which is the smoke that is exhaled by the smoker. There are more than 7,000 chemicals in mainstream tobacco smoke. Hundreds of them are toxic, and about 70 of them can cause cancer. Pipe smoking is strongly related to cancers of the oral cavity, like the larynx, the esophagus, and the lungs. Cigar smokers who inhale can develop coronary heart disease and COPD. E-cigarettes are not any better. We call this vaping. They contain hundreds of harmful substances like nicotine and ultrafine particles that can be inhaled very deeply into the lungs. And this includes, and not limited to, heavy metals like tin, nickel, and lead. Cigarette smoke induces an inflammatory response, and it causes an increase in reactive oxygen species, or ROS. This then causes oxidative stress. We know that oxidative stress can cause and alter many cellular proteins. Cigarette smoking is both pro-inflammatory and immunosuppressive. Tobacco smoke, along with many other factors, influence our epigenetics. So the influence on diet and how it relates to cancer is pretty complicated. Cancer risk in older adults may depend on diet in their earlier life or on their current eating practices. There's a lot of evidence that points to nutritional factors being related to cancer development. Nutrigenomics, that's the study of the effects of nutrition on our phenotypes, which are based on our genomic differences. So our culture and our location geographically does play a significant role in our diet and health. When it comes to something like what we eat, the types of foods that we eat, like red or processed meat, fiber, whether or not we're ingesting alcohol. There's also a geographic migration cancer risk. So people who maybe have migrated from another country to the United States and have adapted the Western diet. Places like Japan have seen a rapid increase of colorectal cancer with the westernization of its diet. Many of our cellular processes are affected by nutrition. If we have an adequate consumption of vitamin A and D, there may be suppression of cancer stem renewal. Foods also influence our DNA repair. Malnutrition can reduce that repair. There are studies out there that consuming kiwis, cooked carrots, or the coenzyme Q10, these have been proved to help DNA repair. And if there is consumption of lycopene-rich vegetable juice, that was associated with decreased DNA damage in the lungs and the epithelial cells. We know we are exposed to many xenobiotics. We've talked about xenobiotics before. Toxic, mutagenic, carcinogenic materials. Unfortunately, many of these are found in the human diet and in drugs. Many of these are transported in the blood by lipoproteins and they penetrate the lipid membranes. So, our body has some defense mechanisms for countering these effects. Our detoxification enzymes metabolize and detoxify the xenobiotics in the liver. Remember, we talked about that in the first pass effect. It hits the liver first after it's absorbed through the GI tract. We also have antioxidant systems. Foods themselves can sometimes play a protective role in metabolizing carcinogens. Leafy green vegetables, for example, can induce detoxification enzymes, and that modifies the carcinogen metabolism and it modifies carcinogenesis. We also have enzyme housekeepers. They're involved in the metabolism of environmental carcinogens and reactive oxygen species. Those who lack these enzymes may be at higher risk for cancer because they have a decreased capacity to metabolize carcinogens. Over the past 20 years, obesity has been increasing rapidly. In the United States, and it's an epidemic. It has tripled since the 1970s, and data is showing that 1 in 5 school-age children are obese. In 2016, 1.9 billion adults 18 and older were overweight. 650 million of them fell into the obese category. The criteria for overweight and obese status is based on our BMI, our body mass index. You can see that table on table 12.4 in your text. Certain numbers correlate with certain classifications. Obesity impacts our energy balance, our cancer risk, and our survival. Being overweight or obese is linked to an increased risk in developing 11 cancers, including liver, prostate, ovarian, gallbladder, colorectal, stomach, and pancreatic cancer. Mechanisms of obesity associated with cancer are evolving. They may vary by the type of tumor and the distribution of body fat. But there's data that points to 3 main factors that impact obesity and cancer. The insulin-like growth factor is one, sex hormones is another, and adipokines or adipocyte-derived cytokines is another one. Alcohol. It's classified as a human carcinogen. Excessive alcohol plays a role in several common cancers, cancers of the mouth, the pharynx, and others that you see on the slide. Know that there is no safe limit of alcohol intake. The effects come from the content of ethanol. It's not affected by the type of drink. There may also be a genetic component that increases our risk of alcohol-related carcinogenesis. Physical exercise is important. It has been reported to decrease the risk of breast cancer, colon cancer, and endometrial cancer. Data does show a vital importance of regular exercise in the primary and secondary prevention of several chronic diseases. That's including but not limited to cardiovascular disease, hypertension, diabetes, cancer, and even premature death. You can see on the slide there are several biological mechanisms for physical activity and how it relates to the protection against cancer. What I want to point out here with this is that you should know is that physical activity increases our gut motility. It helps move things through. Things are going to move through faster when we're moving. That gives it less time to expose our bowels to mutagens. That's why there's a link and to a definite decrease in the risk of colon cancer with exercise. Air pollution is a leading environmental cause of death worldwide. 1 in 3 persons will face a double burden. That's exposure to household indoor pollution and outdoor pollution. Long-term exposure to both of these contributed to 6.1 million premature deaths from stroke, heart attack, lung cancer, and chronic lung disease. Outdoor pollution is a mixture of many known carcinogens. Outdoor pollution has a particulate matter. It's a mixture of extremely small particles and liquid droplets. Many of them are carcinogenic and cause lung cancer. Primary particles are emitted directly from a source like construction sites, unpaved roads, or smokestacks. Secondary particles are emitted from places like power plants, industries, and automobiles. These are fine, ultrafine particles, and they are easily absorbed by our lungs. They're then phagocytized by our macrophage and neutrophil and they release tissue damaging inflammatory mediators. This causes pulmonary inflammation, and that inflammation sets off a cascade, which can progress to possible tumor development. This is just a visual of how small particles can be. The gray line that you see there is a human hair. To the left, you can see how sand size, fine beach sand, is in comparison to the hair. Things like dust, pollen, and mold are the blue circles on the hair. And then the red circles, which are on top of the blue circles, are these ultrafine particles. Indoor air pollution is considered worse than outdoor pollution. A lot of times this is due to cigarette smoke, but there's also exposure from heating and cooking combustion sources that are risk factors for lung cancer. What I want you to know here that besides cigarette smoke, another significant indoor air pollutant is radon gas. This is radioactive gas and it's derived from the radioactive decay of uranium that's found in rock and soil. It can get trapped in houses and form carcinogenic radioactive decay products. That's why some homes need a radon test before the sale of the home. So here's a quick question, which is true regarding environmental risk factors and the development of cancer? The answer is D, that physical activity has been linked to the reduction of breast cancer and colon cancer. Ionizing radiation can also cause cancer. Much of what we know about this has stemmed from observations of Hiroshima and the Nagasaki atomic bomb exposures. On the slide, you can see the increased risk for many types of cancer, including lung, stomach, esophagus, and urinary tract cancers. What's important to note here is that the age at the time of exposure is the main factor. So they were studying Nagasaki and Hiroshima. The leukemia incidence in individuals younger than 15 reached its peak at about 6 to 7 years after the explosion, while those who were 45 or older had a latent period of about 20 years before developing leukemia. This has to do with what's called bimodal distribution, which means that radiation risks at the early ages are related to just an initiation of cancer, whereas exposure at later ages is associated with the promotion of pre-existing pre-malignant cells that were already there. This also relates to medical imaging procedures. We talked about this a little bit in the last chapter. There's a cumulative effect here from these procedures. It can cause oxidative stress, compromise DNA repair, and kick off the inflammatory response. Here's a visual pie chart of the sources of exposure to ionizing radiation. This is on page 277 of your text, figure 12.15. When we talk about non-targeted effects of ionizing radiation, that is referring to the biological effects that occur in cells that are not directly touched by radiation, but are in the vicinity of the cell that has been exposed to the radiation. These cells ultimately can participate in the final damage response. It is a myth that mutations and malignant transformation only occur in cells that are directly irradiated. Irradiated cells have many cell divisions and they express a high level of gene mutation and chromosomal abnormalities. These effects stem from previous generations of cells, and that's called genomic instability. They're studying this instability as it may contribute to secondary cancers. In the cells that didn't receive radiation, there is known what's called the bystander effect. That can also lead to genetic defects. Lastly, with ionizing radiation, I want you to know that it can cause both acute and persistent effects. Acute ionizing radiation can cause damage to several organ systems, especially those that have high proliferating cells. An example would be blood, skin, and the GI. This carcinogenic potential persists as a direct result of the non-targeted radiation effects we talked about on the last slide. There is cell signaling, and it induces changes in the microenvironment. Now that the radiation induced cancer in humans, it has latent periods of about 5 to 10 years, but latency can span the decades. For things like leukemia, it may appear within 5 years of exposure. There is still a need to identify risks from exposure to low-level ionizing radiation. These are things like exposure to radiation from medical procedures. The risk estimates are constantly debated. UV radiation typically comes from sunlight. We can also see some come from electric lights, black lights, and tanning lamps. UV radiation is divided into three major wavelengths: UVA, UVB, and UVC. Most of the UV radiation on Earth is UVA. Some of it is UVB. UVA radiation is weaker than UVB, but it penetrates deeper into the skin and is more constant throughout the year, regardless of the weather. What is tough here is that UV radiation is important to our health. It produces vitamin D, which is needed for the absorption of calcium and phosphorus from our food, which is important to our bone development. So there is a recommendation of 5 to 15 minutes of sun exposure 2 to 3 times a week. When we get into overexposure, however, this is when we see acute and chronic health effects, particularly in the skin, the eyes, and the immune system. There are three major types of skin cancer: melanoma, basal cell carcinoma, and squamous cell carcinoma. Melanoma is the most lethal, and it can occur at any site. On men, they usually find it on the skin of the head or the neck, between the shoulders and the hips. In women, melanoma is more commonly found on the skin of the lower legs, between the shoulders and the hips as well. Basal cell carcinoma commonly occurs on the head and neck, usually from years of sunbathing. Basal cell carcinoma loves light or fair skin tones. Squamous cell carcinoma is found more commonly in men who work outdoors, but it can happen to anyone. In this case, remember that basal is better. Squamous cells are more aggressive. Electromagnetic radiation, or EMR, is a form of magnetic and electric waves. We see this with our telephones, our broadcast antenna, our Wi-Fi, security monitors, and other things. The impact on our health has not really been fully assessed when it comes to the EMR, but the most concerning and extensive studies have been from our use of our phones. The main concern here is for our children. There may be a deep vulnerability there because children are using phones sooner, and we are using cell phones longer and longer into adulthood. Infections. These can contribute to cancer. We talked about one in the last chapter, H. pylori. This is the cause of 75% of all stomach cancers. Hepatitis B and C account for a majority of our liver cancers. HPV, which is the most commonly sexually transmitted virus in the United States, accounts for more than half of the total infection attributable cancers in women. Most sexually active women and men will be infected with HPV at some point in their lives, and some are infected repeatedly. If there's a persistent infection with HPV, it can cause cancer. The two types of HPV that people or clinicians are watching for are type 16 and 18. That's why there are current guidelines that women should have a pap test or pap smear every 3 years beginning at the age of 21. So lastly, there are chemical and occupational hazards that increase our risk for cancer. As you can see on the slide, chemicals are present everywhere in our household products, in our personal care products, our workplaces, and our home. Many cancers that are in our lungs, our bladder, the peritoneum, these are attributed to our occupation. One notable one is asbestos. Asbestos is a heat-resistant fibrous silicate material. It is woven into fabrics and things like the brake linings of brakes on vehicles. This asbestos can increase the risk of mesothelioma and certain lung cancers. Know that mesothelioma is likely to develop secondarily to this occupational hazard. Things like bladder cancer has been linked to those who work for manufacturers of dyes, rubber, paint, and heavy metals. So here's a quick question. A change in lifestyle factors or controlling bacterial infection from H. pylori is responsible for a decrease in which type of cancer? The correct answer is B, stomach cancer.